Hello, dear students. Welcome to this new lecture, which is topic of the subject Oceanography, and which is a course of 4-year undergraduate program, which is a newly introduced, made syllabus for sixth semester. And this is a major subject named Oceanography, and the topic belongs to the Oceanography. And in this topic, we'll be discussing origin and evolution of ocean basins and the origin of seawater. Moving forward, so the first question which arises is, as we know that the majority portion of our globe or planet Earth, it's covered with water. So how did this water actually came into being? I mean, actually came onto the planet Earth, and simultaneously, how was this atmosphere as well formed? So this we'll try to answer this basic question. And before moving forward, let's discuss about the origin of our Earth's atmosphere. So as we know that gases which make up the atmosphere, they were initially formed right at the formation of nebula, when the leftover gases uh, from the nebula, and they composed of the initial atmosphere. And again, but those particles, they were blown out to the space by the solar wind as well. So this was the first atmosphere, and this happened way back in geological, millions of years. And after that, a second atmosphere was formed, and most likely, which was formed by the, expelled from inside of the Earth, composed of the gases which were expelled from inside of the Earth, which is called by a process called outgassing. And after that, density stratification happened, and the lowest density material, it was contained within the earth, which was composed of various gases, and these gases rose to the surface and were expelled from the early atmosphere. So what was the composition of these atmospheric gases? What gases, were taken out from from the interior of the earth to the exterior? And these gases, they have been, similar. They are believed to be similar to the gases emitted from the volcanoes, which we see in the contemporary world or the modern world. We have gases emitting from geysers, volcanoes, hot springs, and mostly the composition is of water vapor, that is steam, with small amounts of carbon dioxide, hydrogen, and other gases. And this composition, however, of the early atmosphere, it was not the same as the today's atmosphere. And the composition of the atmosphere, it has changed over time because of the influence of life and entry of the life, and possibly because of the changes in the mixing material of the mantle as well, because the planet Earth has been evolving, and the adding of life, addition of life, it also changes the biochemical makeup and overall makeup of the planet Earth. So now let's discuss about the Earth's oceans. So the origin of the ocean is linked directly to the origin of atmosphere. Why? Because outgassing, it released mostly water vapor, and this was the primary source of the water of the earth, including supplying oceans with the water. If we'll try to see, we'll just in this figure, we have outgassing in volcanoes. Early in the earth's history, volcanic activity, they released large amount of gases in the form of water vapors and gases in the atmosphere. And this water vapor and other gases, in between that, if water vapor condenses into clouds, and the liquid water from these clouds, it fell to the earth's surface, where it accumulated in the low lying areas or the depressions, you can see the layer here, over the period of time, and formed the oceans. Okay, so this figure explains the basic process of outgassing, and then condensation, and then again precipitation. So evidences, we do have evidences that suggest by at least 4 billion years. I mean, Earth's age is 4.6 billion years. So by 4 billion years, most of the water vapor from outgassing had already accumulated to form the first permanent oceans on Earth. And later on, these oceans, life originated in that as well. So, which is a separate topic to discuss. But recent studies and recent research, however, suggests that not all water came from inside the Earth. So some water it came through via comets as well. So comets, which are extra planetary objects, which are these are composed of about half water. They were once widely held to be the source of oceans. So during early development, space debris left over from the origin of solar system bombarded the young planet, and there could have been plenty of water supplied to Earth in this way as well, because the solar system was developing. There was a lot of debris. Some debris it was thrown out into the outer space. Some debris fall back onto the planet Earth, and most probably the water was also in the debris which came to the Earth and supplied to the water. Uh, addition component of water on the planet Earth. So, however, and, there are some analysis, spectral analysis of the chemical composition of three comets named Halley, Hyakutake, and Hale Bopp. These are the names of the comets which had a near Earth pass. They made in 1986, 96, and 97 respectively, and they revealed a crucial chemical difference between the hydrogen in comet ice and that in Earth's water. So in 2014, European Space Agency's Rosetta spacecraft reached the orbit of a comet to gather data on its ice. Although the lander set to the comet surface failed to send back data, the orbiter was able to analyze the comet's ice and determined that it too did not chemically match the water in Earth's oceans. So, if similar comets supplied large quantities of water to Earth, much of the Earth water would still exhibit the telltale type of hydrogen identified in these comets. Because the hydrogen of the water in the oceans and planet Earth, it differed from the hydrogen of the water that comets brought on to the planet Earth. Okay, so even though this comet ice doesn't match the chemical signature of Earth's water, there are a variety of small bodies in the solar system that could have supplied water to Earth. For example, recent analysis of a comet from Kuiper belt, which is an icy debris disk in the outer solar system, indicates does contain water with nearly the correct type of hydrogen that is found in the Earth's water. In addition to Kuiper belts objects, asteroids, rocky bodies that contain ice and orbit the Sun between Mars and Jupiter also have a similar type of hydrogen and thus could have contributed water to an early Earth. These findings point to an emerging picture of a complex and dynamic evolution of Earth's solar system. Although it seems like that most of the Earth water was derived from outgassing, other sources may have contributed to the Earth's ocean as well, which includes the meteorites and comets. So now let's discuss about the development of ocean's salinity. How did the water become saline in nature? So the relentless rainfall, which we believe happened for thousands of years, and this relentless rainfall that landed on Earth's rocky surface, it dissolved many elements and compounds and carried them into the newly forming oceans. So even though oceans have existed since early in the formation of the planet, its chemical composition must have changed gradually with the course of time. This is because the high carbon dioxide and sulfur dioxide content in the early atmosphere would have created a very acidic rain capable of dissolving greater amount of minerals in the crust than occurs today. And in addition, volcanic gases such as chlorine became dissolved in the atmosphere. So as rain fell and washed to the ocean, it carried some of these dissolved compounds which accumulated in the newly forming oceans. Eventually, a balance between input and output was reached, producing an ocean with a chemical composition similar to the today's oceans. Excuse me. So, this is a slide which shows the animation how the planet Earth is formed, and this is it for the today's lecture. And you can, for further reading, you can refer to the books. These books, Essential of Oceanography by Trujillo and Thullman, and Tom Garrison, Oceanography and Invitation to the Marine Science. Okay, this will be it for the lecture. Thanks. Bye-bye.